I think with at least the even and odd and the cofunction identities, that kind of gives you a little bit of hint of, well, let's at least simplify some of those things, right? So Douglas, when you're looking at this, when you automatically see cotangent and negative x, you think, oh, that's like the even odd identities. The only ones that are even are cosine and secant. So therefore, this is just going to equal to negative cotangent of x. Yes, right? You guys agree?
Yeah.
OK. Pi halves minus x. Oh, that's the cofunction identity. Cotangent of pi halves minus x is the same thing as the tangent graph over sine of x. Now we look at this and we say, oh. Now you could rewrite this in terms of sines and cosines. But don't you guys agree with me that cotangent and tangent are reciprocals of each other? So when you have a number times its reciprocal, that equals 1. So a function times a reciprocal should also equal 1.
Wait.
Dang it. I keep on messing up my answer. Sorry about that. That should be a negative cosecant.
Does that apply even if the cotangent is negative?
Yeah. Like what's negative 1/4 times 4? Negative 1, right? So yes. So therefore, what this gives us is negative 1 over sine of x.
Wait,
What?
how does that equal 1 again? Yeah, that.
Cotangent, these are reciprocals of each other.
Yeah.
Or think about it this way. Cotangent is cosine of x over sine of x. And tangent is sine of x over cosine of x. Right?
Oh, okay.
I mean, they're,
Does that equal 1 if they all cancel out?
cosine divided by cosine is 1. Sine divided by sine is 1. They don't cancel out. I don't think I said that, did I? I said they divide to 1. They don't cancel out. They divide to 1. So 1 divided by negative sine, if we look at our reciprocal identities, we can see that the answer is negative cosecant of x, which is our answer on the right-hand side. Ta-da. That's it.
How would that be asked on a multiple choice question?